these kinds of things like LMT to be really, really interesting. You're very lucky that the organizers of LMT kept making this competition, even though they're doing it now in this ridiculously difficult online environment. So first, I want to give the shout out to them. Congratulations for organizing something like this in the depths of this pandemic. Thank you. Now, that gave us the context for us all to get together here. I understand that I'm supposed to be one of the speakers saying something hopefully interesting to you. And I was actually asked before coming if I could maybe talk about something that might maybe relate. Oh, a parent there. Wonderful. I'm glad to see that we got a parent who decided to come. Right, but I want to talk a little bit about how maybe the mathematics that you're working on could someday be related to something real. What would that be like? Well, for that, maybe let me tell you a little bit of my own story. So I grew up in the United States. I, in fact, enjoyed doing math competitions. In middle school, I found math counts. Or rather, I think math counts found me by accident in my middle school. And I just got hooked. I thought it was really interesting to think about problems where I had no idea how to start. Actually, that's what I want to say. What LMT is helping with, and what all of these math competitions are helping with, is that they're getting you used to questions where you don't know what to do when you start. And those are the most interesting kinds of questions. In fact, that's what drew me to the math competitions. I really enjoyed trying to think about, is there another way to do the problem? Oh, here's a random tip. If any of you are doing math competitions, this thing about finding another way to do the problem is really powerful. Because actually, that's the secret for how you double check your answers. I don't know if maybe you already knew this, but the secret to how you get like perfect scores on all the tests is you try to do every problem in 2 different ways. And if the 2 different answers match, then it's probably right. And that's the whole point. The whole point was, can you think of 2 like really different creative ways to solve a problem? I mean, one of them might be the standard, and then you've got to come up with like a non-standard, which is as weird as possible. Because then if the 2 match, it's probably right. Whereas if you ever have been doing math competitions, you know that if you just do it one way, and if you check it the same way, the second time you'll make the same mistake. That 6 times 9 is 52. Oops, right? Like if you made the mistake once, you'll make the mistake again. But somehow, if the way you went to check is that you said, oh, no, it's going to be 6 times 10 and then minus a 6, then you're like 60 minus 6, that's not 52. You see what I mean? That you want 2 different ways. And I'm just sharing that for me ever since I was doing middle school math competitions. I just did this a lot. Ooh, I see a question. One thing you'll notice is whenever there's a question, I'll lean forward because that's how I can try to read what's here. Decrease the amount of time taken on one problem, right? And this is how I'm going to do this talk. Like as people are typing in things, I'll see if I can, some people can say for the Q&A, that's true too. I'm the kind of person who's used to doing YouTube live streams. And so what ends up happening is that sometimes what I see in the chat influences what I say next. But this whole notion of like, how do you figure out how to save time? Well, I'll go on that in the direction I want to go in, to say that's why you get really good at creatively coming up with totally new ways to solve problems, even on the spot. So that's the training that I had in middle school and in high school. And in high school, I got really interested in these high school math contests. Now, the high school math contests included some things that you write proofs for. And I actually got lucky enough that somehow, due to my scores on these computational problems, I actually qualified one year for this Math Olympiad training program. And I remember when I went there, I looked at all the people around me and I said, these are all geniuses. What am I doing here? I'm some kid from Wisconsin who accidentally got here. And everyone is better at everything. So I think what I will do is I will try to come up with creative ways to solve problems. That's actually what I did. I never was like one of these guys who was going to try to get the highest score because I knew I wouldn't. I knew I couldn't. There were so many super geniuses in the room. How can I come up with the fastest, how could I come up with the fastest solution for everything? But I could at least come up with something creative. And I thought that was fun. I'm emphasizing this because I am sure that not everyone in this room is the best person at math in this room. Obviously, because first of all, there's at most one best person. And I said the word at most because it's not even clear that there's a way to order the people to say that one person is the best. So what I want to emphasize is no matter where you are in this ranking, it doesn't matter. You can always go in and you can say, can I come up with something interesting? Can I come up with some new solution that I'm proud of? This is something that I think I hold to my heart even today. I really enjoy coming up with different things. And I feel that by coming up with something different, maybe that's some contribution that I can give Because in this world, there are plenty of people who can already do the standard things really well, faster than me. So this is an attitude that I got all the way from middle school, high school. Sometimes I got high scores, sometimes I didn't get high scores, but it built creativity. And I use that these days whenever I'm teaching a class too. I saw that somebody here mentioned that they took one of my classes. But what I always try to do, why I even made the classes, was because I wanted to find a way to teach people how to think. Because when I go and think, that was a double use of the word think. But when I go and consider what was the biggest thing I took from the math competitions into real life later, it was that innovation. It was that thinking of some new way to do things, a new idea. And that takes to the theme of the talk I want to talk about today. This is about progress, human discovery, and the way that we live our lives. In fact, if you look at the lives we lead these days, they're pretty luxurious. We've got all kinds of interesting technology. We have comfortable things. We have ways to communicate at almost the speed of light, or actually the speed of light if you use some kind of wireless communications. It's incredible. We have all of these wonderful things. Somehow we still seem to be losing to some virus, but I'll get to that soon. But what I'm referring to is, like, it's really interesting how far we've gotten as a human civilization. But if you think about it, what's involved in getting there? How do you get from caveman to here? Well, I claim there's two kinds of things that are going on. There's one part, which is making steady progress. And I want to emphasize both of these are really important, right? And in this talk, I guess I'm trying to share of how some of my philosophies, and also interlink them with my own story, perhaps from before. But I think of progress as two kinds, right? One kind is this thing where you go and keep making some steady progress. That's actually very important. That's another part of my own life. I enjoy always, whenever I do a task, I want to just outdo what I did last time by even a little bit. And that came from competitions too. Because again, I never went into the competition saying I'm going to win. In fact, I went into the competition saying, oh my gosh, there's some super geniuses from Massachusetts. Surely they're going to win. This is actually what I thought. You guys are from Massachusetts, not very far from Boston, not very far from some of the most famous universities in the entire world. And I'm this kid growing up in Wisconsin. So I remembered always thinking, all the people, everyone except me is somebody who could, do amazing things. So what am I going to try to do? So somebody said, that's you in every single test. Well, let me just tell you, you're not alone. That's how I felt in all of these things. Right? But there is one thing that I felt that I would bring, which is, even if I can't compete with those people from these wonderful places, I can compete with me yesterday. And so can you. You can compete with you yesterday. And it's actually really good to be hyper-competitive with yourself. Don't have to be hyper-competitive with other people. In fact, sometimes that is bad for friendships. I really like people. I don't like to be competing like in that way with other people. But competing with yourself, that's okay. No hard feelings, right? And at the same time, it's something that you should be able to win, because you know now more stuff today than you did yesterday. And I think this is a certain piece that I took from that math competition lifestyle all the way through to everything I eventually went to do. I mean, that's, for example, why I'm even doing these kinds of live stream talks, right? That's because at some point earlier in my life, I said, I know how to do, I guess, in-person talks. I know how to record videos. I wonder if I can conquer the next step and try to figure out how to do these live streams. And there was a time during the summer I had lots of fun. Maybe spring and summer, I had lots of fun doing YouTubes every single day, YouTube lives. Unfortunately, that had to come to an end because I got busy. But I'm still sharing that somehow this idea of whatever you've done yesterday, see if you can do a little bit more today, just a little. And that's actually how humanity makes progress. That's one of these ways. It's actually really important that if you end up someday having a job doing something, figure out what was being done there, and just always see if you can add a little bit more. Just add a little bit more. And that gives a certain sense of satisfaction. I mean, I should say the way that I even think as I go through life of, do I feel happy about what I've done? The way I think about it is there anything new? Did I get anything new? Have I made any improvement? That's actually what makes me happy. And this is another thing tying into math competitions. That's also what eventually boosts your scores, because then you don't waste as much time just like doing stuff that you already know how to do. In fact, it doesn't even make you feel good. Instead, you're always like, gee, is there anything more? And if you just stretch and stretch and stretch, that's awesome. So this is one way that humanity will move forward with all of the things that we have. But there's another way. The other way is actually also extremely important. The other way is what I call discrete. The first way is what we call incremental. Incremental is like +1, right? It just got a little bit better, very important. But then there's another part, which is like the quantum leap or the sudden advance, where there's a huge leap forward in what people are capable of doing. What powers those? Well, usually the only way to make some kind of a technological leap or go to the next generation is with some new idea, new insight, something new. And that new thing oftentimes actually relates down to an idea. And if you think about it, that is actually what has caused humanity to make so much progress. It's because it's a combination of these incremental improvements where we keep polishing things and getting them better and better, combined with suddenly there's a stroke of genius, a new idea, and then suddenly all of humanity is moved up here. And then the incremental growth happens as you go and refine, get better, and then another generational leap happens. And what I want to talk about today is a little bit about how, that generational leap is in fact very exciting. And in fact, a lot of that is powered by deep understanding. And I would say that math is a really important ingredient there. The people who wanted to organize this talk wanted to say something about how math could impact the real world. I have a claim, which is that some of these huge leaps that go forward are actually powered by mathematical types of insights. Now, I don't want to only talk abstractly. So I'm in fact going to talk a little bit about something that I'm working on right now. And it's not to say that that's because this is the most important thing in humanity. It's not. I know that there are many more essential things that are being done all around the world in all realms of discovery. But this is what I can talk about because I've been fighting with it for the last 8 months. So I've invested 8 months of my life so far into doing something, and that's enough to make you an expert on the particular direction that you're working in. So now, what am I talking about? I'm talking about a way of controlling disease. And I'll talk a little bit about what's this new idea, but then I'll also always weave this in with like how a mathematical way of thinking would make you come up with this new idea. So I'm going to talk about COVID. And in fact, I'm going to talk about something that was brought up in the chat, which is NOVID. NOVID is this app that I lead in order to try to eradicate COVID. And today, I'm going to mention that it's not only to eradicate COVID. In fact, just over the last 2 weeks or so, it dawned on me and on our team that what we have come up with could potentially fight every human-to-human communicable disease that communicates through direct contact, which is a very sobering and very inspiring thought, that there could be a new way to fight off all infectious diseases that spread through person-to-person contact. That's actually pretty interesting because we want every way possible to fight diseases. And if there's suddenly a new way, maybe it could go somewhere. And let's talk a little bit about what this might look like. So first of all, yeah, I'm going to talk about COVID, but we can already start thinking about how this way of looking at things could actually extend beyond COVID to actually many other diseases, which is what makes this even more important. So when you think about controlling a disease, for 3,000 years, the same method has been used. Actually, that's not true. There have been many methods, but the method I'm about to name has been used for about 3,000 years. And that is, whenever you have anyone who's sick, you remove them from the society and you remove all the people around them from the society. This is a standard technique, and it actually works, right? It works. If you have people who have some skin condition, actually it's not a skin condition, but it's like leprosy or something, then you remove them from the community, right? But by the way, what I've just described is called contact tracing, and it's a standard way of fighting a disease. If there's a disease person, remove them and all the people around them from the society until they are no longer contagious. Of course, there are other techniques. Other techniques involve medicine, which is wonderful. Like vaccines, drugs, all kinds of those pharmaceutical interventions. But I want to talk about the non-pharmaceutical interventions. Non-pharmaceutical just means not using medicine, right? And the reason I want to talk about those is because pharmaceutical inventions take some time to invent or some time to develop. You cannot, for example, say, hey, I have a new virus. I need a new vaccine now. No, we already know from experience watching this pandemic that it doesn't happen now. So there's a lot of value in non-pharmaceutical. So now let's think. With the way that normally it's done, you go and say for every person who's sick, go and find out who the people are that are around that person, and go ask them all to please quarantine. That's the standard paradigm. I looked at this as a graph theorist. Graph theory is another word for network theory, and graph theory is actually the mathematical way to call network theory. And as a network theorist, I said, you know what? There's something we can do with this network. What if instead, for every person who's sick, you go and tell everyone how far away that person was that's sick, but you tell them how many relationships away it was. What could you do with that? You see, so the flip is, we used to just say, here is the person who's sick, tell everybody who was directly around them, okay? And tell them to quarantine and go away. New way, tell everybody how many physical relationships away is this positive person. I'm drawing a zigzag line because when you count relationships, that's like, you live with this person, that person goes to work in an office with that person, and that person lives with this person who got COVID, right? So I have this like zigzaggy line. Now, if you do that, that's actually called the network theoretic distance. That's called the graph theoretic distance. And you can use that to make a radar. Now, that's actually really interesting because radar, we know, is something that can help you in other contexts like weather or warfare. I'm just going to switch over to here. I want to show a little bit about what this could end up looking like. Suppose what you did is you went and told everyone how far away all of those positive cases were. And then suppose that you drew it on a chart and then you animated it over time. So here, the date is changing, June 4th, June 5th, and so on. And as the date changes, you can go and see how the COVID situation, how the virus situation is changing directly relevant to you. So you is right here. And if I want to explain what this chart means, if there was a bar, if there was a red bar above this spot, which is at degree of connection 1, what that would mean is that you spend time with someone and that person tested positive and got COVID. What would the bar at 2 mean? If there was a bar at second, then that would mean that you spent time with somebody and that person spent time with somebody else and that person got COVID, right? But what does this do? Actually, if you give everyone this radar, this is the first tool that you could use to conceivably stop yourself from getting COVID. Oops, let me play it again. I want to pause it at the exact right time. So I'm just showing like this. Suppose you had a tool like this, and the tool is showing you how the situation is changing. Then if you were able to see as the situation gets hot closer to you, you could actually avoid getting sick. I'm pausing for a second because it takes a while for this to sink in. Why is this important? I've actually just showed you the first app that you can use to reduce your chance of getting COVID. You might say, wait, there's like tons of other apps, right? I've heard of other COVID apps. Other COVID apps, surely they reduce my chance of getting COVID. Well, not really. The other apps reduce the chance of other people getting COVID. So this is now where some math is going to come in, which is pretty interesting. All of the apps that anyone talked about before were where they took the normal contact tracing, which is like, somebody who's sick, tell all the people directly around them to please quarantine. Yes, they took normal contact tracing and they made an app for that. It's a reasonable thing to do. I would consider that to be an example of this like continuous improvement to say, there's already contact tracing. We have smartphones. Let's make the smartphones to do the same thing. Reasonable. What I'm showing you is what we might call a paradigm shift. It's where you suddenly say, let's change the whole idea. Let's not try to tell people to quarantine. Let's try to give every single person in the whole world a radar. And if you compare these two, as a mathematician, we start to isolate out what makes them different, right? And if I go back to the original way, like the old way where the app would tell you, hey, you have, the way the app works for everyone else is that it tells you, hey, you have been around somebody who has COVID, please go quarantine to protect everyone else from you. You see, this is what we do in math. We try to distill down to see what is the difference. And the difference is that's an intervention, which if you install the app, you then protect other people from you if you ever get exposed to COVID. In other words, those are apps that will reduce other people's chance of getting COVID. Does this make sense? Does this distinction make sense? I'm saying all of those apps, if you install them, you'll be a great person. Please do. And you will, by installing it, reduce other people's chances of getting COVID. Whereas what I've just demonstrated here is, if you install this app, you'll actually also reduce other people's chances of getting COVID, just because this is a control mechanism. But you will also reduce your chance of getting COVID directly, because what you do is, as you see the disease coming towards you, you get out of the way. Get out of the way, what does that mean? Okay, I don't know who this person is. This is all anonymous, right? It's just got some numbers here. But what this means is, look, if you saw something get within distance 3 or 2, what does that mean? That means it's getting really hot. I've actually asked a lot of people, what would you do? What would you do if you found out that COVID was within distance 3 or 2? Distance 2, by the way, might mean that your mom's office mate just got it, right? This is hot. So what might you do? People say things like, oh, they would really make sure to wear like a really good mask. Or they would be careful about when they go outside, if they see someone else, they would just keep like extra distance. By the way, this is very powerful because the way that transmission works, as you get farther away from people, that significantly reduces the chance of the disease spreading. There are all kinds of interesting models about this. Although these days, because we are thinking maybe it spreads through aerosols, then maybe that might not be as effective. But we're using that knowledge. You can even say things like, well, if I'm going to go into a small enclosed space, if I can choose, I'll choose not to. Or if you're teaching in a room, which is a small enclosed space, and it's pretty hot, hot like COVID-wise, what would you do? Open a window and help to ventilate the space out. None of this is real time, by the way. The thing that we made doesn't tell you immediately like, hey, right now there's somebody coming up right next to you. However, by having that knowledge that is coming up on your doorstep, you can take action to reduce the chance of getting sick. Ooh, I see a question. What about somebody who's not able to access the app? This is where it gets really interesting. So the first thing is I want to emphasize, what you're looking at here is me standing in front of a bar graph, but really it's the idea is using the mathematics to reframe the problem. For the very first time, you're able to make an intervention where the person who installs the app actually gets to reduce their chance of getting sick. And that's a very powerful statement, which I'm going to hit hard. But now you're asking, what if somebody doesn't get to install the app? There are lots of ways around this. The first is that we've tested this on like very low-end smartphones. And we're not only doing this in the United States, we're actually talking to other countries which are significantly less wealthy than the US. But it actually works on pretty basic smartphones. And if somebody really doesn't have a smartphone, that's also okay. And that's because of the paradigm of the radar. Because all you need is that there's someone who knows them who has a smartphone. Like suppose that in this family that lives in another country, there's only one smartphone in the entire family. That's okay. If that smartphone shows that the radar says that, oh, there's somebody within distance 3 who just got COVID, well then, if that's like, say, the mom who has the phone, then the other person in the family knows that within distance 4 of them, there's a case of COVID. Does this make sense? I'm saying like, if the person with the phone, mom, saw that there's a distance 3 away someone with COVID, then someone else who lives with mom is at distance at most 4. Actually, this is math again. I'm sorry, I geek out whenever math shows up. But why this is so interesting is because we have switched from telling people, hey, you are exposed or you're not exposed, like true or false. We changed from that to telling a number. How far away is it? 3, 4? Once you report a number, then suddenly it's okay to be off by 1 because all these are close enough anyway. You'll already want to be careful at 4 too. Question. How does the app know your social network? Well, that's a lot of work. So that's why it's a smartphone app. What we did is we spent many months making an app for which, if you have an app installed and the other person has the app installed, if you're walking around and you spend at least 15 minutes near them, the two phones actually talk to each other while they're in your pocket. And neither of them knows who the other person is. They don't know the names. We don't know any names. They don't even know any GPS. But while they're talking to each other, they use Bluetooth to talk to each other primarily. And as they talk to each other, they're like, oh, hey, we've been around each other. And that forms a link in this network. So the important thing is that we don't know your social network. In fact, the best way to describe this is it's just a bunch of smartphones which are wandering around in the world, which are automatically discovering that they form this like interesting internet of things. Actually, I shouldn't have used that phrase. That phrase means something. It's not the real Internet of Things. But they form their own network, right? And then what ends up happening is the way the app works, if we're actually working with a school, for example, then the school nurse, whenever they find out there's somebody who's positive, then the school nurse gives a password to the person and they can enter into their app saying, I unfortunately was positive, and that throws a red blip on the radar for everyone else to see. But the important thing here is that it never took the name. And that's actually where the math comes in again. I got super excited in March to build something like this because I saw that from a mathematical perspective, I don't need any names. I don't need any GPS locations. All we need is to form this big grapevine and put a system on it which automatically pulses this kind of radar signal, right? And if you just gave everyone the radar signal, they can avoid getting sick. I now want to hit some more parts, which are actually really interesting from math perspective. This is something that was in a conversation I had earlier today with a person who's actually a leading person who's working on COVID control from a mathematical perspective. Oh, there was a question that came. Ooh, yes. Somebody asked, why 15 minutes? Why not 5 minutes? Why not 10 minutes? Actually, we do more than that. The way that it works is that we just know exactly how long it is. And so we have even different ideas of time thresholds. For example, if somebody's been really around someone else for like all day, then they probably live together, right? And that's like the strongest type of connection. So if you want to know, the practical reason why we say 15 minutes is so that when we show this display, everyone can get it. You see, I've got to choose something to say. And if you tell people the display is just telling you something very simple English, each of those links, 15 minutes. Actually, what we use is 10 meters. That's actually pretty far, but not so far that it's like the next building across the street, right? But so we have this particular distance. And if you have that particular distance, then you declare that means you're connected. And that's it. I can tell you why not 5 minutes, why not 10 minutes. That's because those are too easy to accidentally have. If you're just like shopping and you're in a line, you might take 5 minutes to get through that line and you're never going to see that person again. Okay, but I want to talk about a different mathematical aspect of this. You see, again, this is showing how a mathematician thinks about all of these problems, and that's also how something like this that you just saw might come out of a mathematician. Let's think about game theory. I'm not sure if you've ever heard of the notion of a Nash equilibrium before, but you might have heard of John Nash. John Nash is a very famous person. There was even a movie about this person. Actually, there was a book before the movie, I think. Beautiful Mind, right? And so the Nash equilibrium is something that is sort of talking about things that might relate to some other phrase called prisoner's dilemma. But these are all situations where if you have a bunch of people all trying to coordinate behavior, a Nash equilibrium is one where if you said all these people are behaving in these ways, then if anyone defects, meaning they change their strategy surprisingly, then a Nash equilibrium means that nobody can change their strategy and themselves become better off. The important thing about this is a Nash equilibrium, by the way, can include a situation where actually everyone's worse off than if they all got along. But the problem is because people just aren't, people are people. And somehow if somebody finds out, yeah, I know we were all supposed to do this, but it makes me selfishly better to change the strategy on all of you. So suckers, you're stuck. That's sort of the principle of the Nash equilibrium. And here's the difference between what I just showed you and what the standard paradigm is. In what I've just showed you, the Nash equilibrium, well, a Nash equilibrium, is that everyone actually uses the app. Why? Because if you install it, you increase your chance of survival. And if you uninstall it, you decrease your chance of survival. So like, yeah, I mean, this is assuming rational behavior, of course. But if you compare to the original app, the normal thing, the Nash equilibrium there is that everyone uninstalls. Oh, didn't understand the Nash thing. Let me explain it again. So let's explain it with an example. And the example I'm going to use is the apps that you've heard of, that everyone is using, that everyone was making. In all of those apps, the way those work is that if you have it installed, it will improve the lives of everyone else around you. And that will happen by sometimes telling you that you need to quarantine because maybe it's too late for you, so go quarantine to help everyone else. So a Nash equilibrium would mean if you said, okay, let's see, suppose we want to ask, suppose everyone installs the other app, is that a Nash equilibrium? Equilibrium means that it's resistant to change, right? Then you say, okay, is it resistant to change? Let's imagine everyone has installed the other app. And let's take Joe Schmo. Does Joe Schmo have an incentive to uninstall their app? And the answer is actually yes. Because if Joe Schmo uninstalls their app secretly without telling anyone else, Joe Schmo's chance of survival is the same. Because remember, the way the apps work is if the other people around Joe Schmo have the app installed, they make Joe Schmo's chance of survival higher, right? Because remember, the way those apps work is if those people get told to quarantine, they'll disappear and they won't transmit it to Joe Schmo. But look, if Joe Schmo selfishly uninstalls the app, Joe Schmo's life is also better because he's a selfish person, because he'll never be told to quarantine. And quarantine is something that's inconvenient. I'm not telling you, by the way, to behave in this way. This is actually not good. The whole point of going to school is to go and learn, what should we do? How should we be good people? But when you make an intervention, you got to think about the Nash equilibrium. And the Nash equilibrium of an app which drives quarantines is that people don't install it. But if you have, on the other hand, an app which directly increases your chance of survival, then you slide towards the Nash equilibrium where everyone has it installed. Do you see the difference between these two things? This is actually extremely important. And this is also showing how you might look at things as a mathematician. It's sort of like slopes. It's almost as simple as saying, like, look, if I've got a line that's got a positive slope, it goes up eventually. It just goes up and it just keeps going up and up. And if I've got a negative slope, it just keeps going down and down and down. And so what we have done here is we have realized that, if you give people a radar, it'll increase their chance of survival, and it might also coordinate all of the human behavior. For the person who was asking about the Nash equilibrium, did this make any sense? Or I'm not sure if this helped to explain the situation. I'm basically saying Nash equilibrium you can think of as, imagine everyone is selfish and greedy and only cares about themselves and is trying to find ways. Yes, fantastic. And what I'm emphasizing is if everyone is selfish, greedy, and rational, that's important, and understands how our app works, everyone will install it. So that's actually the difference here. So now going back to this thing and talking more about the mathematics of it, right? Like, what else is interesting mathematically here? Well, one thing is this human behavior aspect, which is what I just talked about. That's cool. There's another thing which is also really interesting. And I'm talking about all of these things. I'm talking about like the particular paradigm that we're using, primarily because I want to show you how, if you, I guess, did a lot of math in middle school and high school, and someday use that mathematical thinking to try something in the real world, exactly how you'd express the key ideas with math and use those expressions of the ideas with math to come up with a better idea, right? And so the next thing is, hey, I've been reading a lot of these news articles actually about all of the other apps. Oh, I also want to say one important thing. When I say all the other apps, that includes what we made. In fact, when I gave a talk to this community, Lexington High School's community, maybe a few months ago, one of the things that we were the most proud of was that our app was very accurate at doing exactly what I just described is not as powerful. So I want to emphasize, I'm actually not here just criticizing everybody else. I'm even showing how my own way of thinking changes as you keep innovating on the same problem for 8 months. You might find out like 6 months in that, oh my gosh, that direction we were going on, which was the same as everyone else's direction, has some fundamental issues. And then you go and steer off. right? So let me continue then about how, as I was looking at all of these other interventions, including what we were doing before, well, here's a problem that was well known that we see in the news. Remember how I said that the red signal gets into our system? And that's also how other systems, other apps get their signal. It's that somebody enters into their phone saying, I'm positive. Unfortunately, not everyone does that. Actually, unfortunately, we now even know the statistics because some other countries have used apps that do the other system. And when it comes time for people to enter into the phone saying, I'm positive, they don't. And you might even be able to see why. It's like somehow there's so many things on their mind. They're positive with COVID. They have to think about other things they have to do. They might be afraid. They might not want to do it. Oh, I see a question showed up. Ooh. Yes, just to answer the question, the explicit question that was just asked, indeed, exactly. If you uninstall the other app, you will not decrease your own chance of survival, because the purpose of the other app is to protect other people from you. I'm not encouraging this behavior. This is very selfish behavior. Please don't do it, right? But I'm saying if you look at it as a mathematical problem, that is the characteristic that the other app has, because remember, the other app's principal way of operation is if the app holder was around somebody else who has COVID, the app holder is told to please quarantine to protect everyone else from them. And that's why what we did is we said, no. Let's make it so that the app directly increases your own chance of survival by letting you see on a radar if something's coming in so you can do something about it. But distilling it down to that point that was just made in that comment is essential. And this is also showing how, if you want to go and think about how to make some kind of an innovation, you want to be able to really separate cleanly what is different here and how important is that difference. And what is different was the phrase that was just put into the comment. Why is it important? I just explained with game theory, with the notion of Nash equilibria. But now let's go on to another piece, which is a big problem, which is that people just aren't entering into their app when they're positive, on any app. Oh no, then our system wouldn't work either, right? Because if there's no red signals, what are you going to do? And practically speaking, it looks like, depending on the country you look at, their statistics of how many people enter into their app that they're positive might be 10% of them, might be 20%, might be 30%, or so on, not 100. Ooh. Somebody said, but if you are one in NOVID, do you stay home? Well, actually, what I would say there is, if you care about other people, which I hope you do, then you would stay home and you would take that maybe as a quarantine request. That would be great, right? But I'm still going to emphasize, for us, the biggest value of the NOVID system is that you ideally would be able to see something on its way in. And before it gets to one, what you really want to do is to get out of the way. I mean, you would want to minimize your social contacts with other people because that's when it's hot, right? And actually along those lines, I often think about how this world would have been very different if this radar innovation, this radar paradigm had been out long before. Like if we look at the map of the US today with COVID, it's a disaster. It's everywhere. But maybe about like 6 months ago, it wasn't really everywhere. There were many counties that didn't really have that many cases. If they had their radar, they would have been able to see the cases making their way in from the city into the county. And they would have been able to raise their guard at the key point to help reduce the spread into their county. And that would have saved like tens of thousands, if not more, lives. The whole point is, if you have this awareness of the disease coming in, it doesn't catch you like surprise. Because right now, a lot of people's ways of reacting to things is, if I see somebody around me has it, then I do something. Like if I see someone around me got COVID, then I might be careful. But COVID's problem is that by the time you know all these other people directly around you who got it, so did you. Because it spreads before you know you have it. I saw there was another question. Yes. So now let's get back to the I'm positive thing, right? Yes, in all app systems in the world, again, I'm telling you like a mathematician, it's a principle that we have to have in order to protect privacy. Every app's trying to protect privacy. You can't go and say like app automatically figures out who you are and grabs the information. No, it has to be put it in. But here's where the math comes in. It's awesome. We already know that the chance of people entering into their app is like maybe 10%, 20%, something like that. For every other app, that's awful because then you're getting like almost no signal. Here's what we do. You see, there is something called contact tracing. I didn't say contact tracing was bad. I was only talking about apps. Contact tracing is good. And the contact tracing that happens usually is that there's somebody in the county who goes and calls people. And they actually want to know, okay, here's a positive person. Who else was around? And actually, the way every app works is that during that contact tracing process, the contact tracer gives a password to that positive person saying, hey, here you go. Now you can enter into your app. And most of them don't enter it. But what we add is that actually during the contact tracing, the contact tracer finds out that, oh, all these other people were contacts of Joe Schmo. Normally, they just get told, please quarantine. In our system, the contact tracer gives passwords to all these contacts also. The passwords let you enter into our app, not that you're positive. Those people aren't positive. But it lets you enter into our app that you are a confirmed contact of a confirmed positive. Now, why is that important? Actually, I don't know. Can anyone else see? I like to have more interactive conversations anyway. Why is it actually still useful? And what can we do? Like, why is our paradigm useful if we find out that this person was a confirmed contact of a confirmed positive? Well, then people can enter that in, right? But it's one away. Yes. So both of these. It's higher probability and it is just one away, right? So the way that our interface works is that we have these red bars and we have another color, we have a pink color. So let's make up a situation. Pretend that you and I are 2 relationships away, okay? Suppose we're 2 relationships away. Suppose I got called by a contact tracer. Oh, so I'm like a contact of a positive. Okay, I entered into my app. Your app will show a pink blip at distance 2. So 2 relationships from you, you know that there's a confirmed contact. What does that mean? That means there's a confirmed positive within 3. Do you know what I mean? If you know that somebody like me is a confirmed contact, well, then just 1 more away is the real deal. And that's useful for your radar. The whole point was, again, once you just go and report these things, which are like, how far away is it? You can afford a ±1 type error. Ooh. Don't they want to delete the app? Even if So I'm catching the main things here, right? The entire point is, for every positive case, as long as that case enters or any of their contacts enter, our system catches it on the radar. Suddenly, this is called an order of magnitude improvement. I mean, again, if the positive case had 5 contact trace contacts, you have 6 chances to enter. It becomes a probability problem you could put on LMT, right? Except that it's even better because you know what? The psychological barrier of entering, I got COVID, is very different from the psychological barrier of saying, someone called me and said that I was around somebody who had COVID. Do you see this difference? Like this is a huge difference. And so this actually increases our chance. Question. So somebody asked, like it's great if we have this way of like, having a radar, but can't we just solve this by having everyone stay in? So you see, the actual reason to make this app is so that you don't have to have everyone stay in. You're lucky that where you live and what your parents do, it is okay to stay in. But the world doesn't work that way. There's a lot of people who can't stay in. I'm not even saying want to stay in. In fact, in order for our world to operate, there are a lot of people who can't stay in. And in fact, what this whole pandemic has done, it's sad. If you think about it, I started this talk by saying how much amazing stuff we have as a humanity. We've invented so many things. And look at this pandemic. What does it do? It makes the entire country have to freeze until somebody finally makes a vaccine. That's awful. Like, what if there's another pandemic, which there will be within like another 5-10 years? And what if the other one's even more deadly? Are we going to sit still again and let this thing happen? We can't. I see questions. Yes. So somebody said, like, what if you didn't test yourself? Yeah. Okay. Actually, you guys are really insightful. I have 3 points of like how this thing is more powerful, and the third point was, oh, there's a lot of people who don't get tested. And there's a lot of people who don't have symptoms. Those are called asymptomatic people. And those two kinds are devastating the situation with all of the other apps. Because with all the other apps, again, they're relying on the fact that there's a positive signal and they're telling the people directly around them to go on quarantine. That's why with what we did, we make this little chart, this radar chart. So the reason why we make this is because even if you're only getting a fraction of the real signal, you see the bars coming from so far away that you can still see that there's movement towards you. And maybe it won't be as sensitive. Maybe like if there's something which is only height 1, you might not detect that. But you might notice that there's this cloud moving towards you because you're still getting a fraction of that cloud. What I'm emphasizing is this is something where people sometimes say, if I see one cockroach, there's like a ton of them. And because of the situation where there are so many people who are asymptomatic, meaning they don't have symptoms, or aren't tested and they're positive, if you see something like this, that's actually why we ask people, you should we don't ask you to, we advise you. You should probably, if you want to keep yourself safer, be careful at distance 3. Because at that point, could be that there are cockroaches which are even closer than 3. But the reason why our system is able to do this is because you can see all of this other stuff, right? When you have all of this other stuff, you actually can just go and say, look, if I'm only getting a third of my signals, pretend every bar is 3 times higher. And if you go and compare it to what was done before, you can't do that. Because what was done before, if I want to compare that, I just have to stand in front of the entire thing from 2nd to 12th and block it all. And that's like how everyone was doing things before. They could only see UN first. And now we show everything. Questions? Yes. So there's actually something about this app. I'm about to just riff on something that was said there. In this particular paradigm, actually, not only does it give you a way to selfishly protect yourself, while protecting yourself, you actually protect other people too. And the reason is because if you are being careful because something got to distance 3, your actions of being careful are symmetric in the sense that if it's protecting you, it's also protecting other people from you in case you're one of those asymptomatic, untested positive cases. Asymptomatic or untested positive cases. You see, because you're avoiding people. And so not only do you protect yourself, you actually also protect other people. That's actually why this is so interesting. I said the word symmetry, and that's also showing how mathematicians think. We always want to know, like, what characteristics are we using? And what we're using here is there's a symmetric behavior. Like this behavior thing is symmetric. It actually reduces the chance of you getting it, and it reduces the chance of you transmitting it. And that's how we deal with these asymptomatic cases or these untested positives. So that's like this innovation in a nutshell. It's actually something where it's quite interesting. If you deploy something like this, you could actually avoid getting sick. And also, what you'd see if it was deployed is that wherever the virus got to, the people around that, socially around that, would be kind of keeping their distance. It wouldn't be a lockdown for the entire city or the state or the country. It would be like a very localized surgical. The guy I was talking to earlier today called it a surgical lockdown, but it wasn't even one that's forced on people. It's just caused by people seeking their own Nash equilibrium to protect themselves. So this is actually a very interesting intervention that could knock out disease, because wherever the disease is, it depresses down what's going on. I see some comments. I'm going to try to read them and hit them. There's so many comments. Wow. And my vision is such that I have to come closer. Ooh. Can your app tell if your school or favorite shop is okay to go to? For us, the answer was no, for privacy reasons, because people don't want anything that's tracking their location that way. So to satisfy that, we didn't do it. But also, that's because you don't necessarily need that piece. The most important part you need is this radar aspect. Wow, more questions. Seen on the news, animals. Oh no, yes. Animals can get it. Yes, this is actually bad news. So unfortunately, it's not just mink. You might have heard of mink. There are also people suspecting that cats can get it. That will make it more complicated. But the good thing is that at least they don't travel that far. And we're not going to give cats phones, right? But somehow that would be like your neighbor. presumably, if you have outdoor cats. But you're right. And actually, what I would say is that all of these transmissions make it all the more important to do something like this soon. Okay, more questions. What percent? Yes. Oh, great. What percent of people need to use this app? Okay, so I love that question because I can both give an answer, which is really awesome, but I can also give a rhetorical question that shows that that question doesn't apply to our system. So here's what I'll say. The first thing is that it turns out that at a very low adoption threshold, especially at a school, it already looks like it works. I'm using the word looks carefully because I'm a mathematician. For that, I'm going to go and share a different screen of something that happened when we released this at a university called Georgia Tech. Georgia Tech is one of the most famous universities in the south of the United States. And so this thing here that you see is, oh, something from Reddit. I share things from Reddit because we are very careful about confidential information, and therefore I can't tell you anything within the app. But if people post on Reddit, I can share it. And the interesting thing here is that the person was saying, this was a student, and the student says this neat fact. The charts are unbelievable. What charts? Let's find out some charts. I'm going to go to their chart. Bam. This chart. So if you look here, I'm standing in front of it, so I'll stand here. What they saw is, wow, 1,000 people using it, 1,000 connections. That's because the app tells you how many people near you are using it. And when we saw these kinds of graphs, we were like, oh my gosh, it works. When I say it, I'm referring to the technology of the app. And I also mean all of the math that underlied everything. Because how to read this? This is not how many positive people. This is just how many people are using it at each distance, right? So there were 2 people who live with this person using the app. Those 2 people were around 3 people. That's a distance 2 from the app user, right? And then it just blew up. The reason it blew up is because as long as our app is a viral app with an R0, which is at least 2, you'll see this. What I just said is that we are actually making a viral app to fight a virus where the viral app spreads on the same network that the virus spreads. Our only objective is to spread faster than the virus. And if you do that, that's what you see here. You see how many people are being connected. Why does it drop off? It's dropping off because the university didn't have infinitely many people. And so there's like not that many more people out on the tail. But this thing happened actually when the university was at around 10% of the people using it. 10%. And you might have heard things saying like, with these apps, they want like 70% of people, 60% of people using in order to make an impact. For us, once we had 10% in a dense environment like that, boom, it connected. That's what made it look useful. And also, by the way, in a normal situation, like suppose somebody was going to a workplace, we estimate that like 25% there is all you need. And you can do the math for this. The way you calculate the math is, I just need that everyone has 2 close contacts using it. How many close contacts do you have who you spend at least 15 minutes with within this distance of 30 feet over any 2-week period? That's how we calculate this. For a lot of people, I don't know, it's like 8 of them. They have 8 of them. I don't mean school, I mean elsewhere. Maybe you have 8 of them. Then I just need 2 out of the 8 to have the app, 25%. And then you suddenly see this like exponential growth. That's very rough, by the way. This is not like hardcore rigorous, but I'm just explaining how you'd think about this. And so what we saw is at a very low percent, you already get people convinced that, oh, looks like people are using it. And then the Nash equilibrium convergence starts. Because at that point, what also happened in Georgia Tech was that somehow, oh, maybe I can find it here. UGA, Georgia Tech. Oh no, I just found the results of a football game instead. Sorry, I was trying to Google for something. I Googled for the wrong thing. But anyway, what I'm trying to say is like once people see that other people are using it, because of the nature of the app to protect you, then it causes it to snowball. And the way I close this question is with every other app, that was a very important question because unfortunately there wasn't this incentive to install. Whenever you think about what percent of people do something, here's the question to think about. Imagine it is midnight, pitch dark, there's no moon, and imagine there are no streetlights. What percent of people turn their headlights on? Is it something which is like, I only think that 10% of people will do it, so maybe we shouldn't bother making headlights? No. As soon as they understand what the headlights do, bam, it's probably like close to 100% turn on their headlights. So I'm emphasizing, like, once you line up with all of the incentive structure, then actually we shouldn't be talking about aiming for some low percentages. In fact, the low percentages are how you can kickstart it. It's like starting an engine for a car. And then once you have that, you just run on the Nash equilibrium, run on the slope of human behavior until you go and get as many people on it as understand. And so that's what this is about. Oh my gosh, there are too many questions now. So let's do this. Wow. What percentage? Leaning forward, would be a good idea to use the app to track vaccinations. Maybe. Actually, we are already adding. Today, we're designing in something where if you get a certain vaccine, you'll be able to report into the app, actually just for survey purposes, like, are people getting this vaccine or that vaccine, and so on. We are actually working on that. Ooh. How long is it given for the people to enter the password? Oh, the password, we're adjusting that all the time. Right now, we're giving like 7 days, but ideally, it should really just be a few minutes or a day. But these are all things that are easy to change. How many people have downloaded the app already? Well, we've actually passed 100K, but that's not the relevant thing. I'm actually not here telling you guys to install the app. It's not really that it would be immediately useful because we need to work with your local medical authorities. I am actually here not to promote one app, but to promote an idea. And maybe I want to close the formal part of my talk this way, because I see we're going into massive Q&A. I'm a mathematician. We make ideas. It happens to be that there is exactly one app in the world that uses this idea. That's because we thought of it and we made the app. But that does not mean that this will be the only app in the world that uses this idea. In fact, I'm already talking to other governments, other ministries of health in other countries other than the United States. It might very well be that some other country you will hear maybe will say, hey, we just got this idea of this radar thing. Here we go. Now they're also using the radar. That's fine. I mean, this is a world of ideas. As a mathematician, my job is to make ideas. What I wanted to share with you instead, as the main principle of this talk, was it's about innovation. It's about disruptive innovation. What can take you to the next level? What takes to the next level is usually something that's a fundamentally new idea. And what you've seen through this talk is that this idea is so different that everything that we thought with the old system needs to be rethought to say, like, how does that jive with this way of doing things? Usually when you come up with a new idea and you do that thinking, your conclusion is, oh yeah, we do it the normal way because this new idea is awful, because it fails because of whatever. But we've just spent like 40 minutes analyzing this new idea through lots of different lenses. And miraculously, it's like it keeps coming up being like, oh my gosh, it's actually more powerful by an entire order of magnitude on that concern, and that concern, and that concern, and it aligns with human behavior. It's like all these things tick. That's what happens when you try to come up with a new idea and you use math. I hope that this talk was somewhat interesting to you guys. It's just a show of how a person who tried math contests, wasn't necessarily the best at them. I wasn't the best at math contests when I was young, but a person who has this math contest background and this particular discipline of how you go about learning for a math contest, which is called do every question in like some weird way. If that's what you take to it, and someday later in your life, you want to go and work on something that has real life implications, maybe you can come up with a different angle. And maybe, just maybe, that different angle could be powerful. My hope is that this idea takes off big time. I'm here talking to you because my hope is that if you also see that the idea is sound, my gosh, we got to tell as many people as possible. Because not only will this help with COVID, I'm looking bigger. I'm looking into what this will do for the future of humanity. My goal right now is to get this idea so widely known and used for COVID that the whole world gets used to the idea of a radar. So that when the next pandemic strikes within 10 years, the first thing everyone will do is to say, quick, power up the radars. And then we'll stamp out that disease long before any vaccines show up. Actually, it's really interesting to be able to say that comment. It's a new way of fighting a disease. All the other ways are valid. We want vaccines. We want antibiotics. We want antivirals. We should do everything. But you know what? We should also use the radar. And what you've just seen is pandemic network radar. Use graph theory, mishmash together with the pandemic signals, make a radar, let everyone know how to avoid danger. Maybe in 50 years, everyone will look back and say, How could anyone have survived before the radar? What did they do? They just ran around and got sick? That's us right now. So anyway, that's what I'm up to. I hope this was somewhat fun for you. And I'm happy to switch to the Q&A part and just like go through the questions.
All right, thank you, Po, for your talk. So now if anyone has any more questions, feel free to put them in the chat. We'll have around 10 or 15-ish minutes for this.
Yeah, we can do about 15-ish minutes. Yeah, that's cool.
Yeah, so yeah.
Hey, you know what? Let's do this. As you can see, I have trouble reading, and that's because my screen is all the way over there and it's small font. I'm totally cool with people jumping out and saying their question. It's so much more fun, and you don't have to turn on your video. I would much prefer to hear a voice. Is that cool with people? Or are people too shy to unmute? Okay, well, I'll answer questions in the chat then. All right, then I have to go and read this. Okay. Yeah. People are talking about how many installs. By the way, I'm not here just promoting to you to install the app. In fact, I don't even think it'll be that useful if you install the app. It's only useful if we can convince your city to go and help issue those passcodes. So I am not here to say install the app now. But I am here to say, if you are in any position to influence what people are thinking, we must get this new idea into the minds of everybody who's making the decisions as soon as possible. Okay, now I'll read the long question. What would happen if store staff at a place like Whole Foods got COVID, but customers were exposed when the items were stocked? Yes. Okay, so somebody is saying this question of like, oh, what if the virus got from a person to an object and then got from the object to you? I make no claim that this will wipe out all the transmission. But the way that math works is that you don't need to wipe out all the transmission. All you need is that every person who gets COVID infects less than one other person. This is called the notion of R naught. Another way to think of it is you want exponential decay, not exponential growth. So you want like something to the power n where the something is less than 1. Therefore, the situation you just described does happen, but it's actually exceedingly rare. The most common transmissions are actually from like some kind of an actual contact. So what we are trying to do is we're actually just trying to let you know, here's how the virus is approaching you along like the most likely network that would infect you, right? And in that sense, it's not promising you protection. I didn't ever say that installing the app makes you invincible. But what I did say is installing the app will reduce the chance that you get infected because you just might get an alert that says, whoa, something's there. And now is a good time to take caution, right? And that's actually all I need. And if you think about it, in fact, actually what you just described, there's another way to mitigate it, which I hope you're doing anyway. If you go shopping, you wash your hands after you get home. That's a really, really good practice, especially right now because COVID is everywhere. Whenever my family goes out shopping, it's like, oh yeah, I'll give another random tip. COVID is everywhere right now. We, in fact, invested in a few N95 masks. We have the normal cloth masks also, which we use in normal times, but now it's totally awful. So we're actually using the super careful masks now if we go into those crowded places. So it's like what you just described, there's another way to mitigate. Okay, more questions. Yes. So the next thing is, what if there aren't many people using the app and it tells you, hey, it looks clear? This is where the communication and the education are really important. The app is not a coast clear signal. Fortunately, you actually get a sense of how good your radar is from that blue chart that I just showed you. Because you can see like how many people there are using the app at each distance. If you go and find out that your radar has like 2 people on it, then like what's the big deal? If it tells you nothing, you're like, oh no, well I have nothing anyway. So it is useful that the app already tells you how big your radar is. However, there's a chance that those people don't enter. So we actually tell everyone with the radar thing, you can't ever say like it's clear. We don't know that. Think of this as just something which occasionally tells you, whoa, something's up. An analogy is if you have one of those newer cars, some of these newer cars, if you're driving on the highway, it might give you a beep, 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 beep if you are getting out of lane. but you can't rely on it. You can't go and say, I'll now drive with my eyes closed. Of course not. But you are thankful that it went beep, 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 because then you go back into the lane. Does that analogy make sense? Like that's all I'm trying to do here. Ooh, question. What about an elementary school? Yes. So the good thing is that the schools would be notified. But the second thing is, actually, our app doesn't only work on phones. We just got it working on Chromebooks. And we also got it working on Macs, like Mac laptops. And we also have it working on tablets. So in fact, depending on the elementary school, it's actually possible that we can also have this thing working inside. And this is an example of what we think about as well. The glitching. Yes. So it is actually a problem, indeed. If the app starts glitching, that'll be a problem, wouldn't it? And that's why what we need to do is make sure that it doesn't glitch. So what you said is, what if too many people get on? And that's where another part of math comes in. I'm just going to do a shout out now to computer algorithms. I don't know if there are any people here who really like computers, but actually for me, when I was doing math competitions in school, I was not only doing math competitions, I was also doing computer algorithm competitions, which are really fun. Those are things where the task is write a computer program to compute all of this stuff really fast, and you're going to have a ton of input. We have a team that we built to go and build the algorithms that are behind this app, which contain many people who are on these computer algorithm programming contest teams. And so we actually made sure that the algorithms we use to compute and say, here's how far away those those infections are. Those algorithms are fast. They are not slow in the sense that if the number of users balloons, that the runtime does not grow quadratically, if you know what that means. The runtime only grows slowly. It grows barely faster than the number of users. It's actually like n log n, if that makes sense to you. But we were very careful to think about how this whole thing would scale, so that if for some reason, like 100 million person country just decided to join, it wouldn't be that we go, sorry guys, we only designed our app for like however many people. No, actually from the get-go, all the algorithms were designed so that if we suddenly saw a balloon, we actually know we could even, in theory, it should even be able to handle into the billions. And I'll tell you why. It's because the computers have billions and even trillions of bytes of RAM if you get the right computers on this thing called the Amazon Web Services Cloud. So we thought about these aspects. Wow, more questions. So why 15 minutes? Okay, let me hit that one first. And I saw there was another unrelated question, which is cool. I'll answer that too. But like, why 15 minutes? Again, it's just because that was convenient to explain to people. But the good thing is that we can actually change that. We're in full control of how we design this network. And we found that 15 minutes was reasonable. It also happened to make the least amount of confusion for people because they were used to reading about 15 minutes from the CDC guidelines. So we just felt, let's use the same number. But the beauty of math is you can always change it. If we found there was a better thing, we just change it. And that's very easy for us to do. Another question. How could proofs be crafted in a creative and formal manner? Oh, okay. So actually they can. I really enjoyed doing that. So when I was doing proofs in high school, I would often try to think of like the intuition behind a proof. A proof is a very long story. And if you try to ever do something like the USAMO or USAJMO, sometimes you look at the solution and you're like, I guess I can understand every sentence, but how in the world did you think of putting those 30 sentences back to back? I mean, this is what I would think when I read these things. This is true. And so if you want to make something like a proof explained in like some more creative manner while still being formal, it can be useful to explain the intuition of like why you might care to first do this and then do that and then do that. If I wanted to give an analogy to what we just talked about today, it's like this whole thing of I went to go and emphasize just now about how our intervention uniquely directly benefits the app user by reducing their chance of getting sick, whereas the others don't. So that's like one point. And then the second point is, now let's talk about this whole Nash equilibrium thing of like why it actually makes sense from a human behavior perspective that is such an important piece. So to me, when I think of a proof, even if there are 30 sentences, I think of it as, here's a key point, here's another key point. Once you put the two together, it's done. All right, now let's go and talk about this first point and understand it. Now let's talk about the second point and understand it. And sometimes if I could tell like an analogy or a funny story, I would do that too. Another question. What was your favorite math problem that you ever worked on? Oh my gosh. I actually like all of them. If anyone's ever watched my live streams, you will know that if I see a math problem, I enjoy the thrill of the chase. And that's actually why I don't play favorites. I'd say that if it's a question I look at and it's like, yeah, I've seen that before, it's not really that much fun. But if anyone's watched my live streams, the times that I get the most excited are when I'm like, whoa, I don't know what to do here. Let's try this thing. And then I just want to beat it. Beat it meaning like I just want to figure out what's going on here. And so that's what I would answer. To me, they're all interesting, preferably the ones I don't know. If you ask what do I think is really interesting that I've ever worked on, I would actually say this thing that I just was talking about just now, like using this math to look at how to control pandemics in a totally different way. That at this point is the most interesting thing I've ever worked on because I also care about real impact. Of everything I've ever worked on in my life, this is actually the one that quite possibly will have the biggest impact forever.
So, hey, Dr. Loh.
Yes.
I'm a parent. I really thank you for this wonderful talk. It's very creative app. So based on your way you described that, I still don't get how would the app suggest me to move? If I get to 3 or 4, would the app suggest I should quarantine myself? Because it would suggest me to move away from that red area, right? But then how do I know that I'm going to move in one direction, change my social life? Would I even get closer to a even redder area? Or would it be just better that I just quarantine myself and then separate from the rest?
Oh, so first of all, thank you for unmuting and thank you for asking. I really enjoy hearing another voice. So here's what I would say. The app doesn't tell you where, right? It just tells you it's somewhere coming close. Here are explicit things that people might do. They might make it so that whenever they go out in any public place, like if it's a workplace or anything else, if they're then they keep an actual increased distance from other people than they normally do. Sometimes people actually let their guard down and get a little bit close to others. Here you would be very aware that something is up. Other things that you might do, if you have a choice, you might work remotely. I have an office. I have people who work with me on this app. And we routinely have periods of time when people say, you know, it seems like it's a bit hot. And then they'll just work from home for like a week. It's totally okay.
Okay. Yeah, I'm actually an essential worker, so I have to go to work. So if that is a red area, I think...
Then let me tell you what I would do. And this is exactly what we're doing right now. If you're an essential worker, if you're working in a hospital, maybe you already have these things, but it's just there's different kinds of masks, right? There's the normal cloth mask, there's a surgical mask, and then there's the N95.
Right.
I would actually go full into the N95, but on that, maybe you already have been wearing N95 every day for the last year, but for many of the rest of us, we can't afford that and we don't have that, so we just use those on the key occasions.
Okay, great. Thank you.
Yeah, sure. Thank you. And thank you for raising the question. Basically, the best answer for essential worker is on these days, wear N95.
Okay, yeah, that will make sense.
Yes, sure. Thank you. And as anyone else who's listening to this conversation can see, every single person would be able to make the best judgment for themselves with their circumstances that they have. And that's why it's important to build things that align with human behavior. Because suddenly we have this conversation now of, okay, what's the best way to protect myself? Lots of people are very interested in having this conversation. And once you empower the individual to go and say, find best way to protect myself, then they do. And so that's just like, that's how we look at these things. Cool. Is there another question here? Oh, yes. How should you work on a really challenging math problem if you don't have a long consecutive time period to work on it? Oh, yeah. I would say it is useful to have a long time period. When I was in high school and middle school, I'd do this on weekends. Then at least I don't have just a tiny little sliver of time before I go to bed between school and sleeping. So I would do stuff on weekends. And there is value in actually sitting and focusing on a question for a while. for example, I'm telling you that this question I'm working on, this COVID control, pandemic control, it's been all I've done. I've just done this for 8 months. I do encourage you, like it's really interesting to dig into something for a long time. And what else here? Question earlier that got lost. How does help? Oh yeah. How did math help you come up with the radar radar idea originally? Well, you see what? The thing that's interesting is that I came up with this in June. And when I came up with it, I was just like, yeah, it's cool. I didn't know it would be useful. I mean, I was just like, yeah, you got a network. You can show network distances. It's a cool thing that we can do. Let's add it to the home screen. And at that time, I didn't really have this true sense of how it could change how people fight diseases forever. So I think the important thing is, I've also talked about this to other network theorists, and all of them say the same, which is like, yeah, it's obvious. If you happen to be a network theorist, what I described to you, it's just obvious. But maybe there just weren't that many network theorists who were like thinking for 8 months about how to stop pandemics during a pandemic, right? So I think this is just showing, if you go and sit on a question literally for like 8 months, it took me like 6 or 7 of those months to realize that this obvious thing could be shoehorned in a totally different way that matched with human behavior. And even this thing I told you about Nash equilibria, that is an insight I had today, like today. That's how fresh all of this stuff is, right? Like even before today, I was just like, it seems like it's better, seems like it aligns with human behavior. And today I was like, whoa, from a game theory perspective, it all makes sense. So anyway, I'm just showing like that's how this all comes together. You just sit on something for a long time, use anything you know from math, from human nature, from biology, from science, and just like keep slotting it in. But ultimately, how the radar idea comes, it's just network theory. This is why you should learn math. If you learn math, you learn like these random other tools that could it ever be useful? Well, maybe. Okay. How did you get past the part that you didn't know what the steps were, but you knew every part? I'm not sure I understand that question. So I'll just answer a slightly different question. It's like, how do you get past? I mean, for me, like getting past something would be, if that thing is important enough, I'll just keep fighting with it. And like if I can't beat a problem, I'm actually quite curious. Oh, more like to understand every part. Actually, would you be willing to just say your question? That would be a lot easier for me.
More like how do you because you probably for like a question you you understand all the steps, but you just don't know how to do it. How did you like guess past that part?
I know what you mean. So this is like when I said, oh, you have 30 lines of a proof, and how I get every one of them, but how would you think of putting them together? Is that your question?
Yes.
Yes, I've had that before too. And I'll tell you what I did. I just tried to do it myself. It takes more time. But what I would do, and here's a trick. I would be like, oh no, I don't know how to do this problem. Fight with it. Doesn't succeed. All right, fine. How am I supposed to do it? There's some solution, right? I go and just like read the middle few sentences, and maybe it says something, maybe it's a geometry problem. And maybe it says something like, hey, draw a circle where the diameter is this, and look, there's a right angle. Then I would just like stop reading the solution because I don't get it anyway. And I'll go and think, that's a hint. So now let me do this problem. Somehow I'm supposed to draw this circle and use this right angle. Does this make sense? I take it as a hint. And then I keep fighting. I'll go think for longer, like 15 minutes, 20 minutes. If I still don't get it, then I go and look at the solution again. And now I don't look at the middle, I look at the 1/4. I'm bisecting it. I'm cutting it in half. And eventually, after I've cut it in half enough times, I can actually piece everything together using them as hints. And then I say, I know how to do the problem. And then I might read the solution and I'll be like, oh, yeah. That's why you do this and this and this and this. But that's because I own it now. I actually came up with those steps with the hints. Did that help?
Yes.
Yeah, great. And I think I'll take one last question because that's right here. So it's like, what's your take on setting times and standard procedures for doing problems will promote making different or non-standard or innovative approaches? I don't think I completely understand the problem. Would you be willing to just say your question out loud, since this is going to be the last question I take today? I'm happy to just hear it from you and give you the best possible answer. If not, I'll play the eye test again. Okay, so I think I'll just interpret the question in a slightly in the way that seems to make sense to me, which is like, what's my take on like setting times and also promoting these creative approaches, right? So if you are really focusing on time and the speed and just trying to get as efficient as possible, remember the method and do it, unfortunately, you won't develop these creative and innovative approaches. So I strongly believe that the best way to prepare for a math contest is actually to get practice thinking. Because in the end of the day, unless you're really special, you're not going to be the champion anyway. I never thought I'd be the champion. I never was the champion, right? But it's just like, what can I get out of this experience? What I can get out of this experience is that I learned how to think about something. So then actually you can do the math contest practice without caring about the time limit. Just get the problems done. You know, like those are really neat questions. See if you can think through them. You learn more actually from preparing for the contest than from the actual contest itself. And while preparing for it, who cares about the time limit? These are just good questions. Think about them. And you can use the method I just gave as that tip. If you don't know how to do it, go look for a hint by reading the solution in the middle. And then go and beat the problem. Like every problem is there for you to beat. And you know, eventually you do. On the actual contest, yeah, I agree. There's an actual contest. Do your best with the time. Try to get the highest score you can. After the contest, maybe play with the questions some more. But just remember, what we're doing all of this for is to learn how to create and learn how to innovate. And if you do that, then hopefully, who knows, maybe 20 years, 30 years from now, maybe you'll be the ones who are in some position that the world needs you to think of an idea. I'll be too old by then. I probably won't be the one thinking of anything like that. So I sincerely hope that one of you will save. So with that, I'm just going to say thank you to everyone. I hope that you guys had as much fun as I did. Good luck on your contest that you're working on. Enjoy your talk tomorrow. Stephen Wolfram is a very, very interesting person. Do go to it. And in general, just like be ambitious, keep thinking of things. And, you know, maybe you can actually make some real impact on the world. And don't worry if you think you're not smart, okay? Like that's a very important thing. If you think you're not smart, don't worry. If you think you're not the champion, don't worry. There's room for lots and lots of people. And it might even be a good thing that you think that you have more that you want to learn. Good luck, everyone.
Thank you very much. I know I learned a lot. I'm sure we all learned a lot. And yeah, thanks for being here and giving us this talk. It was very wonderful.
Thank you. Bye.
Hi, Dr. Loh. Can I ask one more question? I know it's very late for you. It's a long time. How do I know if NOVID is working in my area? Because you mentioned that you still need to talk to local officials about applying this one, right?
Yeah,
how do I know?
Unfortunately, it probably isn't. And the reason, unfortunately, it isn't is because it is not in many areas right now. It's in almost no areas because it's such a new idea that people weren't comfortable with it. In fact, as I said, only recently did we realize how powerful this is. So we know that right now it's in virtually no areas. However, if any of you know anyone who's in this medical profession or public health profession, if we can get the idea elevated up, we can change that. So
yeah, I really would like to talk to my leaders at my work, like to really say, oh, yeah, we should promote this one because you totally convinced me that this is a great app. Not only that it would protect other people, also protect myself. If we have this information, then instead of until you identify someone to be positive, then you ask them to quarantine. Then when they get to 2 or 3, then you can start doing, hey, can you please quarantine yourself? Even though you are essential worker, please take off a week. And then they can totally protect the other colleagues. That would be wonderful.
Well, thank you. Thank you for your support. I have been talking to enough scientists and public health officials recently that my impression is it's only a very short amount of time we think before this is going to become widely known. You guys on this talk basically are among the first people to hear this and hear this take, but it could very well be that, who knows, in a few weeks or in a month, maybe this is going to be all over the news as, my gosh, new way to do these things. And at that point, we hope that this will explode across the US, hopefully just in time to take out the next surge.
So
thank you for your support.
Are you doing anything to promote this one?
Yeah,
the NOVID?
I'm actually doing a lot to talk to the scientific community. It doesn't work so well in just giving advertisements. I am actually talking to people who maybe are researchers at Harvard or at other universities to try to get this idea up and up and up as fast as possible.
Okay, great.
Yeah, so I'm working very hard on this.
Yeah, I definitely would like to promote this one as well. Thank you.
Yeah, thank you.